In this video, we'll have a chat about digital forensics. Digital forensics is the collection and investigation of digital data. The term triage relates to this in that it allows for the prioritization of forensic tasks, whether we are going to a suspect's premises to seize equipment or data on the equipment, or even trying to seize data stored in the cloud. The integrity of evidence needs to be maintained. We must follow the chain of custody so that we can always track who had access to collected evidence and where and how it was stored. Hashing allows us to get a unique value for data that can be used in the future to detect changes. So therefore, we can verify a hash prior to analysis of seized data to ensure that it matches the acquisition hash, so we know that nothing's been changed. We can also use tamper-proof seals for physical evidence to ensure that data is kept safe and equipment. All activities need to be documented when gathering and then storing evidence. Data sources for digital forensics includes network transmissions, log files, data files, even the swap files that are used for temporary storage of memory pages, as well as active memory RAM pages, which could include information related to active network connections at a specific point in time or running processes running at a specific point in time, which could be crucial in getting some kind of a conviction in a court of law. Naturally, if we're going to use these data sources, they have to be trustworthy, as do the date and timestamps associated with them. Other data sources include disk partition tables, the contents of boot sectors, file allocation tables, which are used for every file system on a disk partition. Things like cloud backups might be used. So if we seize a suspect's mobile phone, for example, there might not be anything incriminating on it, but if we track its access to cloud services, there might be something that was backed up to the cloud that could be of value. And in some cases, cloud backups are automated, which might even be unknown to a suspect. Then, of course, digital forensic media can gather data from removable media, which includes USB thumb drives and external hard disks and so on. Forensic analysis then analyzes the data after we've got an acquisition hash. Now, the term big data is being thrown around a lot these days, and it refers to the large volumes of data that must be processed to look for something meaningful. And that certainly applies to forensic analysis, because depending on how much data is gathered, there is a specific amount of time that's required to parse and produce results from those large data sets. So often what gets used in forensic analysis are some kind of clustering solution, such as Binary Pig on Hadoop clusters, where we've got multiple computers working together to process data. And this is also easily deployed in the cloud, where we can very quickly spin up clusters for big data forensic analysis. And once it's finished, we can then deprovision it so we're no longer paying for the use of that clustering service. For example, consider the Amazon Web Services that are available with users that have accounts to Amazon Web Services. If I scroll down on the main page under Analytics, I can click on EMR, which is Elastic MapReduce, which is a managed Hadoop framework to basically run large-scale analytics on large data sets. So from here, I can click on the Create Cluster button to begin defining my configuration to process large volumes of data, which could be very useful for forensic analysis. In this video, we discussed digital forensics.